This is section 3.6, Polynomial and Rational Inequalities. Okay, so we are going to be solving things where when you multiply everything out, you have a polynomial and it's an inequality, and also when you have fraction-like things and an inequality. Now, you've probably done, or you've definitely done, linear inequalities, ones where we did, after everything was all multiplied out and simplified, we did not have an exponent larger than 1. So we had something like x plus 2 is greater than 0. And we were able just to do algebra and solve this, and you know, it was fairly easy. Now, we don't have quite as nice of an option for solving nonlinear inequalities. Now, one way of thinking about solving this is if you were thinking about having a graph and you were to graph this line, one way of thinking about the answer to this is when is this value larger than 0? Or when is this above the x-axis? Okay, so when is it above? Or when is it below? You know, depending. Now, with a line, there's always just two distinct regions where it's true, or possibly, you know, maybe it's flat or maybe it's vertical and you have a special case. But in general, you're able to just solve this. When you have a polynomial, you know that that graph can dip above and below the x-axis. And so you will likely have multiple regions that are part of your answer. And then the same kind of thing happens with a rational inequality. When you think about how to graph those, you could have multiple regions that are above or below depending on what you're looking for. So that's where the extra complexity comes in here. Now, we're going to start off with polynomial inequalities. The first thing you want to do is you want to have a 0. And that's because we think of it this way as above or below the x-axis. Zeros make everything nice. They're easy to solve. Okay, and one of the skills we have learned is how to find zeros of a polynomial function. And so that will help. Okay, after you have your 0, whatever it is, then you factor the other side, and that's done for us. Okay, then what you do is you're going to find the zeros of this. You set each of these equal to 0, and I'm writing out this step here, not because you really need to see it, but just so it's here if you come back to your notes and you're wondering what happened. Okay, now, and then I'd solve this and get x equal 3 and x equal to 5. What I have just found are the two places where I cross the x-axis. So that would be the potential area where I cross from negative to positive or positive to negative. Okay, so now that you've got your zeros, what you want to do is you're going to make a chart. Think of this as a number line. In fact, we can draw it in. What I want to do is I want to place these values in the correct order on my chart. So that's a 3 and that's a 5. Now I'm going to extend these down to a chart. And on this side, I'm going to write down my factors. So I'm going to write down x minus 3. I need it spaced to right here, so don't put it directly here. And then I have x minus 5. And then I draw a line underneath here. Okay, so I know that my graph potentially crosses my x-axis. Think of this as my x-axis. Maybe it's going like this and like this. So I have a region where it's above here and below here and here. Or maybe it comes and does this, you know. And this is a quadratic, so we know it's a parabola. But in general, it could come down here and touch it and not really cross. So it doesn't change signs. It's positive all the way, and then it jumps over to negative. So we have to plug in some numbers. We have to figure out the sign. If you think of this as a number line, what we want to do is we want to pick a number in each of these regions. So something smaller than 3. Well, I always use 0 when I can because 0 is the easiest thing to plug in. And then a number between 3 and 5, I'm going to use a 4. And a number larger than 5, we'll go with 6. Now, I believe the book has you plug in these values and actually do the arithmetic every time. It's not necessary to do all the arithmetic. All we are really interested in is what the sign is. Now, what I mean, if I plug in 0 right here, 0 minus 3, that gives me a negative number. Okay, and this is particularly nice when you're dealing with fractions and things where you can see that you're going to get a positive answer, or you can see that you're going to get a negative answer, but you don't want to have to go through the entire process of getting the exact answer. If I plug in 0 here, 0 minus 5 is negative. 0 minus 5 is negative. Now 4 minus 3 is positive. 4 minus 5 is negative. 6 minus 3 is positive. 6 minus 5 is positive. Okay, so what is it that I've done? What I have here is if I plug in a number in this region of the number line, so something smaller than 3, when I plug that in, I get a negative here and a negative here. When you multiply those two together, two negatives, I'm not worried about the exact answer, but if I multiply two negatives together, I get a positive answer. Okay? Again, in this, if I plug in a number between 3 and 5, I'll get a positive here and a negative here. Positive times a negative is negative. And when you plug in a number larger than 5, they're both going to be positive, and you get a positive answer. Okay, so for the first time, I look at this sign. Everything I've done so far is completely independent of that sign. Now what you need to ask yourself is, okay, well, I know what regions it's positive, negative, and positive for. What is it I'm looking for? Am I wanting this thing to be above or below the x-axis? Well, I want this to be bigger than 0, so I'm looking for positive answers. And I'm positive in this region of the number line and this region of the number line. I'm positive in two areas. Okay, so now we are ready to give our answers. If I think about this as the number line, it starts off at negative infinity. Negative infinity. And it goes up to 3. Now I have to decide whether or not 3 is part of my answer. If this has strictly greater than, that means this is going to get parentheses. If this had been greater than or equal to, I would be allowed to include 3 because it would equal 0 when I plug that in, and it would have a bracket. Now since I have two regions, I have to do union and then do the other one. And the same thing happens with this 5 as an endpoint. It's going to be parentheses, and it goes up to infinity. Now you're going to be asked a graph. And you would have your answer. Now if you were to graph this polynomial, it would end up, you would have, this is just a sketch. I'm going to cross the x-axis at 3 and at 5, and it's positive and then negative and positive. Now, I don't know all the details about how far down this goes or how steep it is or anything else, but I know it's going to have that basic shape. Okay, so let's try this one. X squared minus 2x plus 1 is greater than 0. The first thing we need is a 0, and we have that. Now we want to factor this. Well, 1 is a perfect square, and if I multiply x and 1 together, I get just x, and if I double that, I get 2x. So that means this is a perfect square trinomial that factors as x minus 1 squared greater than 0. Okay? So what makes this 0? 1, and 1 is the only thing that makes that 0. So I'm going to make my chart, but the only number I put on it is a 1. Okay? And now I have all of my factors, which is simply x plus 1 squared. You could list it twice, but you're going to end up with the same answer. Now, if I imagine plugging in a number smaller than 1, I get 0. A number larger than 1, let's use 2. 0 minus 1 is negative 1, but then you square it, so you get a positive number. So overall, it's positive. You're not multiplying anything together here. And if I plug in a 2, that's 1 squared, which is also positive. Okay, so what have I found? If I think of it as a graph, I know I have an x-intercept at 1, but it's positive on either side, so it just touches and goes up. If that was a 0 of multiplicity 2, it doesn't cross the x-axis, it touches. But what does this mean for our answer? Well, first of all, are we looking for this thing to be positive or for it to be negative? We want it to be greater than 0, so we're looking for positive answers, which are here and here. Okay, well, you might be tempted to say all real numbers, and it might still be, but we have to check, because at 1, we get 0, and 0 is not positive, and 0 is not negative, so we need to see if we are allowed to equal 0. And if you look right here, it does not have an equal to on it. So basically, everything but 1. Is part of the solution. It is positive everywhere but 1. And that means we're going to have to describe each of these individually. This is going to be from negative infinity to 1, parentheses, not including 1, union, don't include 1, to infinity. And your graph would look like this, where that's a 1 and it switches in both directions, and it's just shaded everything else.